Assalamualaikum and hello everyone. Today I will present our MAP 575 project entitled The Ministry of Higher Education in Numerical Analysis. My name is Nur Farhanani binti Fayudin and this is my partner.
My name is Nik Shazad Isian binti Hanizah.
The Ministry of Higher Education is responsible for managing and improving higher education in Malaysia. It works to ensure quality education, support university development, and increase the number of skilled graduates. So, in this project, data from 20 Malaysia public universities in 2024 is analyzed using the least square regression method. Both linear and quadratic regression models are developed to identify trends and evaluate how effectively student intake predicts is the number of graduates. So, the objective of this study are first to construct linear and quadratic least square regression models that describe the relationship between student intake and graduate output. Second, to interpret the regression coefficient and explain their significance in the context of higher education performance. Third, to evaluate the accuracy of each model by calculating the sum of square errors or SSE. Finally, to compare the SSE values and determine the best fit model for representing the dataset.
This slide displays a dataset from 20 Malaysian public university in 2024, focusing on two key variables. First, variable X, which represent the number of student intakes, and variable Y, which represent the number of graduates. Looking closely at the data, UiTM leads with the highest volume in both categories, recording 75292 intakes and 51575 graduates, while UPNM represent the smallest scale with an intake 281 students. In our analysis, we will use this dataset to perform statistical analysis and explore the relationship between university intakes, sizes, and their graduate outputs. Moving on to our mathematical analysis, this slide shows how we apply the least square linear function to model our data. By solving the normal equation set up in this matrix form, we obtain our linear regression equation, which is y equal to 0.6641x plus 450.76. As visualized on the scatter plot, there is a very strong positive linear relationship between the number of graduates and student intake. This is highly supported by our R-square value of 0.978, which indicates that approximately 97.8% of the variance in student intake can be explained by the number of graduates produced. This slide shows how we calculated our formulas to find the best fitting line for our data. On the right, we created a table to calculate the total values for x, y, x squared, and xy. By putting these totals into the matrix formula on the left, we found our two key numbers. First, y-intercept, which is a0, is 450.76, and our slope, which is a0, is 0.6641. This slope tells us that for every additional student enrolled, the number of graduates increases by about 0.66. Putting it all together, we get our final prediction formula. Next, we calculated the accuracy of our linear model by finding the sum of square of error, which known as SSE. To do this, we compare the actual number of graduates against the predicted numbers from our formula. Square the differences to eliminate negative values and added them all together. This gave us a total SSE of 47290,234.43. This large number is normal, given our huge university student population, but we will use this specific value as a benchmark to compare our linear model against quadratic function.
This slide presents the least square quadratic regression model obtained from the analysis. Based on the calculation, the coefficients obtained are A0 equals to 2120.8, A1 equals to 0.388, and A2 equals to 0.000004. These values are substituted into the quadratic regression equation to obtain y equals 0.000004x squared plus 0.388x plus 2120.8. The scatter plot shows the relationship between the number of student intakes and the number of graduates in Malaysia public universities in 2024, while the curve represents the quadratic regression model. From the graph, we can observe a positive relationship between student intake and graduate output. As the number of student intakes increase, the number of graduates also tends to increase. Okay, the quadratic curve follow the pattern of the data point and provide a better representation of the relationship between the two variables. Therefore, this model can be used to estimate the number of graduates based on student intake. This slide shows the process of constructing the least square quadratic regression model. The general form of the quadratic regression equation is y equals a2x squared plus a1x plus a0. Using the data collected from 20 Malaysian public universities, the values of the coefficient were calculated using the least square method. The values obtained are a0 equals to 2120.8, a1 equals to 0.388, and a2 equals to 0.000004. Substituting this value into the general equation gives the quadratic regression model y equals 0.00004x squared plus 0.388x plus 0 plus 2120.8. Here, A0 represents the y-intercept, A1 represents the initial rate of change in graduate output, and A2 represents the curvature of the quadratic model. These coefficients are used to describe the relationship between student intake and graduate output and to develop a model that can be used for prediction. Next, we applied the same error analysis to our least square quadratic function to test its accuracy. Just like before, we took the difference between the actual graduates numbers and the prediction made by our quadratic curve, square those difference and sum them up. This gives us a total sum of square of error SSE of 374,05832.7079. If you compare this to our previous linear model, you will notice that this error value is noticeably smaller, which brings us directly to our final conclusion. So that's it from me. So we'll go to next conclusion.
To conclude our project, we compared the performance of our linear model against a quadratic model by looking at their final error values. As you can see in the table, the quadratic function has a lower sum of square error known as SSE, which is 37.4 million compared to the linear function's 47.3 million. In statistics, a lower SSE means the model's prediction line sits closer to our real data points with less error. Therefore, we can conclude that the quadratic function provides a significantly better fit for mapping the relationship between student intake and graduates across Malaysian public university in 2024.